National Addressing and Cadastre Model Standards in Australia and New Zealand. Nicholas, thank you.
Margie, do I get you to do the slides or can I do them here? Get you to do them. Okay. He has the power. All right. What control? Thanks, everyone. I'm not quite going to talk about those standards. I will talk about those standards, but that's not the only thing I'm going to talk about. What I'm actually going to talk about is new ways of doing standards generally from a technical standards creation point of view, and those standards represent the new way, or at least some of the elements of the new way. And so this is an innovation in standards session. Before I talk about that, I just want to mention from the last couple of talks, a couple of interesting things I heard mentioned. So one is that Australia is actually pretty well served in terms of standards innovation. So we have in the room here contributors to the WMS standard, the first version, Rob over there. And we have also DGGS moving ahead and Spark Systems. So, we've got a history of contributing in great depth, I think, to these standards. So let's hope that this new approach and so on that's going on now is further contribution. Okay, so next slide, please, Margie. So really just two things from this presentation: new expectations for standards, and these expectations, where do they come from, who has them, what they are, and then new roles for standards organisations. And I'm going to make some personal assertions about what standards organisations can be done. Next. Okay, so new expectations for the standards. Well, and I'm going to, I see, I can see it there. That's more easy. Okay. So these are based on, let's see if I can get this, innovating in the microphone. Okay. So these expectations are based on new standards that come along and people see them in action and think, oh, I've got standards, I want them to do what those things are doing. So that's where the expectations come from. Who has them, I'll talk about in a second. But these are the expectations. There's an expectation that standards give you more stuff. There are more offerings from the standard. So you're not just getting a document, you're getting stuff, goodies, toys, a little show bag like we got on the way in, where you have the standard and it has things with it. And as it says there, comprehensive technical and non-technical documentation, validators, separate code lists, all this stuff. That's kind of an expectation now. If we see a standard in certain sectors that doesn't have that stuff, we think that's kind of old. We expect more. Next. More systems independence. We have had standards that have been system independent standards for a long time, and the TC is a good example. We have conceptual standards, we have schemas and so on, and they are by design system independent, but the requirements for independence are growing because there's even independence from the schemas, in fact, that we've had are now kind of expected. Next. Broader compatibility yet more customization. So when we're doing large-scale national spatial standards, say, we really do have to be compatible with international standards. It's not appropriate not to be, even though we don't always get there, Brian, but we should do that. And yet there's a desire to really cater for individual things too. So we've got to be upwards compatible, but yet locally localizable, or whatever the word is. Next. Parts but a whole. So we are starting to see standards that are reusing mini models within them, or mini pieces of standards. And they're not just a monolith. This isn't the standard that's got everything you need in it and that's it. No, this standard is in fact cobbled together out of bits. And the corollary to that is, next point, please, Margie, which is it's the standard is a whole thing, but it's part of a bigger ecosystem of stuff. And next again, please. So let's just look at those in a bit more depth. So firstly, though, who's expecting these things? Okay, so in the spatial sector in Australia, we have the ratification of a national addressing model now and a cadastral data exchange model. And on the back of those, there'll be some other ones too. There'll be a potentially, or very likely, a place names or geographical names model coming out. And those standards are in that new way of working, which we're going to see a bit more of in a second. So those models and standards are in operations, in Queensland. They are required for use by the West Australian government in their new soon-to-be released request for quotes for a large body of fundamental work. And other states and territories are also moving to adopt these things. In the biodiversity sector, we see similar types of standards that have been adopted as a national standard, ratified by states and territories, and are now getting into operations. In the resources sector, again, interjurisdictional bodies have bits and pieces. They're not as sort of strongly defined, perhaps, as the standards here, but we do see proposed geochemistry data exchange standards, which look like the kinds of standards we will be seeing a bit more of in a second. And that sector is really moving. So it's not just in our little spatial world, it's in these other worlds. And interestingly, those other worlds are dependent on the spatial standards. So when you talk about things to do with geochemistry, you soon end up at boreholes. How do you manage the spatiality of a borehole? The same way we do spatiality everywhere. So these things are moving ahead, but actually dependent. Next, please. Okay, so what do we mean by the more offerings? What do we think, or what do we see some standards doing that we wish all standards were now doing? This is just a table of contents from the address model. You could have called it the address standard, but address model is what it is. And these are just the headings, and you can see what it's actually got in the standard. So it's got metadata, preamble, introduction, sure. It's got the model, that's great. Then it's got a section on vocabularies, and if you were to read that section, what it actually says is, this model requires vocabularies to be used. The vocabularies are not here, they're over there. And the over there is a list of dynamic registers of vocabularies. So you can see where I'm getting to with what I want the standards organisations to do. But nevertheless, that is now a sort of a slightly different way of doing things. Those annexes are important too. The requirements are just a listing of tying this model back to the actual problems it's solving. And in this case, the requirements come from the kind of strategy documents for Australian addressing. So we have a tie back to kind of long-term thought in this space. And we have Annex B, validation. There are schemas that can be used to validate data that claims to conform to this model. And actual tooling, it says, you know, use this tool to do it. By the way, this is generic. You don't just have to use our tool. You can use, in fact, any number of tools to do this. This particular addressing thing allows you to print stuff out in templates. So that Annex C is a bit unusual. Not all standards end up there. But certainly the validation, extended examples. We don't want a standard as we have had in the past, which have no examples. That's not okay. We need lots of examples. We need examples in data and in pictures and so on. And again, that's what we have. Next, please, Margie. So this is just a screenshot of not one of our standards tooling, but it's the so-called portal for the Australian Biodiversity Information Exchange Standard. And this thing allows you to upload your data and test whether it's valid according to the standard. This is not particularly new. We've had things like that forever. We've had metadata entry tools or testing tools for many, many years in Australia. But the point is that this is now becoming expected. Some standards had them in the past. It would be crazy to implement a data exchange standard that didn't provide you with a validation system these days. Next. More system independence. Okay, so again, we have had standards for many years that have had conceptual and schema splits. The conceptual thing is conceptual and it's quite independent of any system. The XML schema is independent of some kinds of systems, but it's not independent of XML. And we now see standards which have that conceptual bit. They have multiple schemas, actually, that can be used, JSON and otherwise. And they have vocabularies which are independent, in fact, of any schema even. So the vocabularies that are used, you can use them in JSON, you can use them in XML, but you can also use them online as a thing to look up and actually, you know, as a human use. So they're quite independent. And validators as well. So that's what I mean by this growing requirement for independence. I'll just mention one last thing here too, which is we sort of always assumed that the databases that are used to store stuff according to standards are relational. That is no longer the case. We've got discrete global grid systems, we've got graph databases, all kinds of stuff which are not relational. And so some of the assumptions that we've had about system independence are like, yeah, independence between Oracle and Postgres. That is not enough independence anymore. We have to be independent even of that. Growing expectations. Next, please. Okay, so broader compatibility, yet more customization. Now, the main standard I'm thinking of that really does this to death is the ICSM 3D CSDM, so Cadastral Data Exchange Model, which Rob is the lead editor of over there. That standard, it put a lot of time and effort into ensuring that there was a core of the standard, and then there were profiles specifically made within the standard creation process for jurisdictions. Another model that didn't spend the money doing that, but is ready to do that, is the address model that you see on the screen there. And there's the address model. It is a profile of different international standards, as in data that is created according to this model, will conform to those standards. Likewise, there are things that profile it. So Queensland has a slightly sort of enhanced version of that. Next, please. Now, the way in which this profiling actually occurs isn't just sort of random. It's not guesswork. It's, as the picture says there, and I'm just trying to read my own writing here. Yeah, it's typing. I should be able to do that. What does to be a profile actually mean? We have formal mechanics for that. That itself is a standard, not in the spatial space, of course, but it's an information standard as to how you say that this thing is a profile of that. And in the standards that I'm talking about here, that formal mechanic is implemented. So it's not just guesswork. It's a formal description of what it means to be a profile, how that occurs, and it allows for certain things like compounded validation. So I can validate my data according to the core standard, and if I want, according to one of these profiles. Maybe I don't need it to be conformant to the Queensland profile, but I do need it to be conformant to the core and so on. So that's part of the way these things work. The cadastral standards and the addressing standards are all doing this similarly. They were developed independently, but they use the same profiling mechanics. Next, please. This is just a pretty picture, I suppose you could call it, of the profile hierarchy in the CSDM model. And the reason I'm including it is just to show that this is so-called one standard, but in fact, it's a series of modules which profile a series of standards. It's a collection of things. It's got many parts to it. It's not just one monolithic thing. Next, please. A couple of other things which add to the possibilities in the way you might do profiling. So we have the formalized mechanics of profiling, international and other standards. We also have kind of conventions for profiling that allow regional or jurisdictional profiles of standards to be made that don't actually change the underlying thing, but certainly make it a lot easier to use jurisdictionally. Now, in Australia and New Zealand, we really only use English as the language, but you can imagine a language change would be one of those things where there's actually no change to the model, but the language superficially is different. We do allow for the reskinning of names and labels and things, and the extension and change, to some extent, the alteration of the code lists and vocabularies that are used within standards. So all of those things, those kinds of differences can be formally accommodated without actually altering the standard itself. We've worked on this now for many, many years to allow more flexibility, yet retaining the conformance of information that's created according to that. So again, this is now kind of what I would expect to see. If someone says they're making a profile of a standard, I'd want to see the mechanics in place that they can do cool stuff, but it's still compatible. It's not incompatible. And we have cases where profiles are actually incompatible. Next, please. Parts, but a whole. So I've kind of mentioned this with that picture of the CSDM model, but we have an object now, a standard, which is not monolithic. It's made of little parts. So the address model actually only implements 3 new classes of object, but it directly uses a series of micro models as well, which were implemented just before it for things, common tasks that shouldn't just be in that standard, but are used all over the place, such as compound naming, life cycles, vocabularies, and so on, oddly spelt there. But these are mini models, ones that we either got from somewhere else or that we've implemented here, but they are generic, and the standard very explicitly is the union of all of these mini models, these parts. This is not a new concept, but it is implemented a bit differently. We are, these days, publishing those mini models quite deliberately. The lifecycle model that's in use in the address model is a published mini model. It's a sort of it's not quite nationally standardized in that way, but it is published through an Australian government group to be used in this way. And so there's a different methodology in place. So when we're making a standard now, we expect to make a bunch of parts and inherit some parts and join it all up together. Next slide, please, Margie. So one of the advantages, in fact, the main advantage we get from doing that is that we can publish a model like the address model and all these parts. And when we come to do a related model like the geographical names model or the place names model, we realize that most of the parts that we want are actually there because place names share life cycles, they share compound naming, they share spatial object managing. All the stuff's the same, really. So the geographical names model, which is not standardized yet, but we hope it will be soon, it also only implements a couple of things and then just mixes and matches from other places. Next, please. This is, in fact, a life cycle stage model. And I wanted to show this because that's the whole model. It's only got 3 things in it. And that model also uses elements from other existing models. But it's quite nice to have it published as a mini model rather than saying, yeah, anybody doing modeling out there, you can model life cycles using a bit of temporality, a bit of this, a bit of that. Sure. Here's a mini model for life cycling, which does exactly those 3 or 4 things. And then we can just reuse that. Next, please. Okay, now probably the most interesting thing that's sort of derivative of some of those other innovations in the modeling is the whole but apart. And what I mean by this is when creating the address model and the CSDM model, we knew that what we were doing was creating a model which must stand alone. You must be able to use this thing without reference to anything else. You're just doing addressing, that's fine. However, you must also, if in the future were to be presented with other models, be able to use this with them. And so what other models are there? You'll see in a second. But at least in Queensland's case, we've got an address model, a cadastre model, a cadastral data exchange model, a geographical names model that all work together. And so what you see on the left there is the so-called supermodel, which is the Queensland Government Spatial Section's kind of overarching integrative environment in which there are a number of models. And this is exactly what the TC211 set of models look like, but the TC211 models are a bit more fundamental. These ones are quite domain specific, you know, they're addressing and hydrology, whatever they are, but they are constructed in the same way. We can make models that are individually useful, but they integrate very nicely with other models as long as there was that kind of vision to do this in the first place. And I think we have that vision for spatial stuff now. It's quite tested, and I'll show a couple more examples in a second. In fact, next slide, please, Margie. So this is an unrelated domain to us, sort of. It's the mining sector. The mining sector in Australia has a crossover with the spatial sector, of course. The institutions in some cases are the same, like Geoscience Australia, but the domain, of course, crosses over. There's a lot of cadastre use in mining and mining tenements and so on. The Geological Survey of WA has another supermodel, which has all of this stuff that they're interested in that we're not interested in the spatial world, you know, things to do with minerals and whatever. But they have similar background models to what we have. They have similar component models, and they have that similar desire to say, look, we want to make stuff that we can use, a borehole model or whatever it is, and we want to be able to keep compounding these things into bigger and bigger envelopes. And again, nothing new particularly about doing that as a concept, but the execution is different these days for a number of reasons. And it's mostly down to that individual micro model publication and reuse through kind of semantic webs sort of technologies. Next slide, please. Okay, so within the spatial domain, what does this sort of theoretical supermodel look like? Well, we've got structural models right down the bottom. These are the things that actually show us how to, or give us the tools to do the modeling in the first place. So you could think of UML in that space, but in the semantic web space, it's OWL modeling, JSON LD schemas, Shackle for model validation. Those are the kind of structural models. And on top of that, we have fundamental models, which are domain specific, but the domain can be a broad domain, such as spatiality. And we've got things like GeoSparkle, which is an OGC standard, and soon, hopefully, to be a TC211 standard. We've got ISO 19160, which is an addressing standard, and we've got these mini models like compound naming, small model, broadly applicable. So it's a fundamental model in that sense. On top of that, we have domain models, addressing and cadastre, the 2 I've talked about here, but place names, you can think of others. And then on top of that, we've got these individual profiles of those things, which may be just of one model, but could even stretch across different models and join things up. Where does all of this whole but part go? Next slide, please. It goes here. Now, this is a screenshot from the Foundational Spatial Data Framework webpage, which lists all of the Foundational Spatial Data Framework themes. And you could imagine that we would have models, what I would call component models or mini domain models for every one of those themes, and in fact, maybe several per theme. And yet, and they work in isolation, the hydrographic stuff in there through the hydrographic office, maybe it works perfectly well for hydrography, but they also work together. And to achieve that, we need new roles and so on for organizations, and that's what we're going to come to next. Next slide, please. Okay, so new roles for organizations. This is new stuff. We're doing new things. There must be new roles here. We can't just have the same people doing exactly the same thing and expect a different outcome. So we do, 1 minute. We do have to have organizations able to publish minier models than they have done in the past. We do have to have dynamic registers provided. rather than just static things in documents. And that's something I was talking about in the ISO TC211 meetings earlier today. And as always, we've got to work together across standards organizations. Last slide, please, Margie. Oh, there was a picture there in that last one, which just shows a bit of new tech from the OGC. It's just an online delivery tool for standards and code lists and so on, but it's got a lot of extra features and so on beyond what we've had in the past. Next slide, please, Margie. Okay, so this is my opinion, but the organizations that are listed there, and you can go to the final slide, Margie, which is just taking my opinion away. The OGC is doing the most technically advanced stuff when it comes to providing different kinds of assets, different publication mechanics, different levels, forms of access, and so on. I think the ISO TC is on the cusp of doing similarly and will be very powerful when it gets there. It's got a big cohesive set of standards, and we want to see those things kind of distributed in new and interesting ways. The World Wide Web Consortium is a bit on the side, but it provides us with some of the technical model mechanics, and it's very innovative in that sort of space. ICSM, I'm hoping, is going to emulate the international organizations and provide us with the capability to publish and use individual elements of models and codes and all that sort of stuff. And Standards Australia has played a little bit in this space too, but isn't quite there yet. I would like to see a bit more innovation in this space at the technical level to allow us to then do the new style of modeling. Thank you.
Very much, Nicholas. Again, yeah, really thought-provoking presentation. Does anybody have any immediate questions apart from questioning Nicholas's opinion? No? Yeah, I do think that you're onto something with the small parts thing. I do think there's a lot of repetition in a lot of standards. And I know that obviously at the OGC, with their API set of standards, we're starting to talk about a language of building blocks, which I guess is a similar sort of language to exactly the same sort of things. So if there's no questions, thank you very much, Nicholas. Thank you.